Perhaps you've heard that Microsoft Teams message extensions can be used as plugins for Microsoft 365 Copilot. This allows the artificial intelligence inside of Copilot to work with business data alongside of Microsoft 365 content, all at the same time. In this video, you'll learn how to build a message extension that becomes a Copilot plugin. We'll dig deeply into the code and other details so you can write a more effective plugin using this method. Now, if you're new to the concepts, please check out my overview video, which introduces message extensions, shows how they work in Teams and Outlook, and then how Copilot can use them in several scenarios. There's a link in the description below. Then come back here and I'll show you all the details on how to build one. This is what's called a search message extension, because a user, or Copilot perhaps, can search some business data and bring the results back. Before we dig into the code, let me show you just a little bit about the architecture. Traditionally, and in this example, Microsoft Teams communicates with message extensions using the Azure Bot Framework. This is a great way to provide fast and secure two-way communications between Teams and your application code. We're also working on a new way to build message extensions with only an open API declaration. This will be easier, but perhaps not quite as flexible unless you can rewrite the code behind that API. Users use an application such as Teams or Outlook, and Azure Bot Services provides a channel that's just a communication channel, not the same as a channel in Teams, to communicate with your application. Microsoft 365 Copilot uses that same Microsoft 365 channel to talk to your app. And the REST calls that go between the bot services and your application send special messages called invoke activities that convey the clicking of menus, the returning of results, etc. So even though it might not look like a bot, message extensions use the same mechanism to send menu clicks and data that you would use in a chatbot to send chat messages. Now you might ask, how does Teams find this bot that's connected to your application? And the answer is that it's in the app manifest, which is a special file called manifest.json that's part of the application package. This also includes a description of the application so Copilot knows what it is and can call it when appropriate. So let's take a look at the manifest. Up at the top, we have some general information that's displayed in Teams, Outlook, or the App Store. Notice that we have fields for name and description. These are key in helping Copilot, as well as humans, to understand what the app is and how to use it. Notice the lengthy description here. It's definitely a best practice to provide plenty of detail in the app description for Copilot to better understand the app. Make sure you mention that your app works with Copilot. Scrolling down, you can see that there's a section called Compose Extensions. Compose Extension is the historical term for a message extension, so this is where the message extension gets defined. First of all, you can see that there's a bot ID. This is the bot that will be used to communicate with our message extension code, which is really just a web service. In this case, Teams Toolkit will register the bot and insert the correct ID into the manifest for us. Next, there's an array of commands. I'm going to save this first command for last, since it's a bit fancier than the others. So here we have a command with the ID discount search. It has one parameter, which is the category name. The command returns a list of Northwind products within that category that are discounted. That's it. If you want a list of discounted products from a particular location, for example, this command can't do it, but it works great for discounted products within a category name. Scrolling down a little, we have a revenue search command. Again, it has one parameter, which is a string that conveys a numeric range of revenue values. The description is especially important here because it conveys the format of this query string to Copilot. Copilot correctly passes the keywords high or low, or a range of integers as shown in the description. It's cool that users can prompt using different language. Find products with revenue greater than 50K, for example, and Copilot will read the description and pass a formatted query 50000-, which is the format that the plugin can understand. Now, let's go back and look at that first command, which is inventory search. This command is much more powerful than the rest, and that's because it has 5 parameters. Although the Teams user interface only knows how to display one parameter, product name in this case, Copilot can access up to 5. For example, it can find beverages that are low on stock by using the category name and inventory status parameters. Again, Copilot uses the description to learn how to format each parameter. This brings us to an important distinction between Copilot connectors, like the Microsoft Graph Connector, and Copilot plugins like this one. In the case of the Graph Connector, it's bringing your data right into Microsoft 365 so that Copilot can work with the data directly. In the case of a plugin, we're giving Copilot the ability to do real-time queries with your data, which has its advantages. It is real-time. However, if your connector doesn't support a certain query, then Copilot isn't going to be able to look up the information. So as with any application, you want to start by thinking about the user and what kinds of prompts users are likely to make, and make sure that your plugin provides the queries necessary for Copilot to do that. Okay, now let's run the message extension with all 3 commands and all those parameters directly in Microsoft Teams. I'm in a chat session with Rabia, so I'll begin by entering a message for her. And then I'll click the plus sign and pull up the Northwind Inventory message extension. Notice that there are 3 tabs here, one for each of the commands. I can enter a product name into the first tab and easily find the product. I could also select the discount tab and enter a category or revenue and enter a range of revenue values. For now, I'll just enter a product name. Notice that I'm showing my console down at the bottom of the screen, and the code logged what we received, a request for product name equal chai. In addition to the small preview, if I click on chai, I get the full adaptive card, which I can send along with my message. Now I can click on Take Action, which exposes a child card where I can make some changes. Rabia found an extra case of 25 units, and she can update the stock level right here on the adaptive card. Again, note the log message, which shows that the message extension has received the new quantity in stock. Okay, this time I'll do it more slowly. Just typing the letters CH, I get a list of all products whose names begin with CH. If I continue typing and then pause for half a second, Teams will issue a new query, this time for chai, and my code returns only the match. Now, I mentioned that Teams user interface only handles one parameter, but I want to be able to test my code. So I added a bit of logic that allows me to comma separate up to 5 parameters in the input box for just the first parameter. The second parameter is the category, so now I can type comma bev to find all the beverages. The third parameter is inventory status, so I can enter comma comma out, as in out of stock, to see items that are out of stock. The fourth parameter is supplier city. Let's see what products are supplied from London by entering comma 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 London. Finally, let's try the fifth parameter, which is the numeric range for stock level. Entering comma 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 0 to 30 does a query for the items with less than or equal to 30 in stock. The key is that these parameters are additive. So for example, I can find beverages with 0 to 30 items by providing both of those parameters. So now let's try it inside of Microsoft 365 Copilot. And I'm going to go with kind of a complex query. What beverage is in high demand due to social media that's low on stock in Northwind in London? And you can see that it constructed a query with beverages, low stock, and London. What you might or might not notice is that it found a document inside of SharePoint talking about our social media promotion around one particular product, around those protein shakes. So it's able to answer the question precisely based on what it found in Microsoft 365, as well as constructing a complex query for my message extension. Now I want to show you the source code, but before I do that, let me show you how I got started. In case you want to build one of these yourself, what I used was Visual Studio Code, Teams Toolkit version 5.2 or greater, Node.js 18.something, and you'll also need a Microsoft 365 subscription where you have permission to upload applications and where Copilot is enabled. So on the Visual Studio Code tab, I'll create a new app. I'll select Message Extension, Query Search Results, and TypeScript, and I'll give a name to my application. Let's just call it TestME. Now Teams Toolkit will generate the source code for my application and open that up in a fresh copy of Visual Studio Code. So let me bring that one to the front And all I'm going to do is click F5. And I'll speed this up a little bit, but Visual Studio Code is doing all sorts of things like installing node packages, setting up the bot registration, generating the Teams app manifest, and bang, there we go. And then it'll launch my application. So I can actually come in here and use it from Teams. And what this default one does is it just searches NPM packages. So if I type Teams or Teams FX, I'll get all of the packages with Teams FX, and I can insert a little hero card with that information. Now let's try it from Copilot. I'm just going to say search test ME for Teams FX. And it's smart enough to find Teams ME was my application and to do the query for Teams FX. And not bad. It worked without any modification at all. However, it's kind of limited. For instance, suppose I want to know which one is the most popular. Well, it has no idea. Why? Because the message extension only has one parameter, name, and no way to look up that other information. So as you can see, it's really important to provide parameters that will allow Copilot to answer the types of prompts that people will use. As with any application in anywhere in computers, you kind of have to start by thinking about what does the user need and what kinds of prompts is a user likely to ask, so that Copilot has the parameters to answer those prompts. It's finally time to take a look at the application source code, and I'm going to start here in a module called searchapp.ts. This was actually generated by Teams Toolkit when I created my message extension. And although I've modified it some, it still has the same basic structure. We're bringing in several symbols from the Bot Builder SDK, including Teams Activity Handler. And then we're extending the Teams Activity Handler with our message extension. Every time our app receives a message through the Azure Bot Framework, one of these functions is going to be called. For example, when a user or Copilot issues a query, handle Teams messaging extension query is going to get called. And all we're going to do here is switch based on the command ID. Remember those command IDs in the manifest? Well, each one of those command IDs is defined inside of my little command modules, if you will. And then if I find the correct one, I'm going to call handle Teams messaging extension query inside of that command. We'll take a look at that code, but first let me just show you, we're also going to handle the adaptive card actions here. So when somebody clicks on one of those action buttons, it's going to call on invoke activity to get called. And then we're going to have to go look at the activity name and at the action verb, which is the little tag that's on the button, on the action button, to dispatch to the correct handler. Now let's take a look at one of these command handlers, and you can see here I've defined command ID to be inventory search. That matches the inventory search command inside of the manifest. And here's the function, handle Teams messaging extension query. As you can see, we're going to kind of try to take the first parameter, query.parameters of 0, and split that out into smaller parameters. That's to handle that test case. Otherwise, we're just going to pull things right out of the individual parameters, and that's the way we'll receive them from Copilot. Then we'll actually search for the products and find the products that match the query, log that, and then go through them. And then what we'll do is we're actually going to generate two cards, a very small hero card, which is just used as the preview when somebody's picking which product they're interested in. And then we're also going to make a result card, which is the full-sized adaptive card. And we send back all of the result cards along with the previews. In a Teams message extension, you have the option of overriding a selected item method and then swapping in a different result card at that time. But Copilot doesn't support that. It expects all the result cards and preview cards at the time of the query. The other thing to notice is that I had to write this little cleanup function because sometimes I had extra space in either from the user entry or from Copilot. And sometimes Copilot would use a wildcard character when I just wanted a blank or an empty string. So I had to kind of code around that. So let's take a little detour and look at the adaptive card part of the solution. The adaptive cards are just JSON files. The first one you see is the edit card. So let's take a look at that. And I'm actually going to paste this into the adaptive card designer so you can see how it works, which you can find at adaptivecards.io. So on the left, we have the JSON from the adaptive card, and on the right, we have some sample JSON that's identical to the products that we get from the search query. So if we scroll down a bit, you'll get an idea how this works. Here we have a text block. You can see it visually on the card and in the JSON. You can also do data binding with this $ squiggly notation, and that's going to take the data from the product information and bind it into the card. Now let's take a look at how the actions work. If I scroll down to where they are, down at the bottom of the card, you'll see I've got an action set, and the first one is an action.show card, and that actually shows and hides a little child card that has the other details on it. So this is the text field where you could enter the stock value, and that is txt stock, and we'll see that back in the code. And then action.execute posts the data from the card back to the message extension. So now let's take a look at the TypeScript code that makes these cards work. And we're in a module here called cardhandler.ts, and you've actually seen us call a few of these functions from elsewhere in the code. Inside of the message extension command, when we wanted to get the adaptive card, the result card, it called this getEditCard function. And what it's doing is it's taking the edit card JSON, binding it with the data from a product that we're being passed, and returning an adaptive card. And then if you remember back in searchapp.ts, when somebody clicks on one of the card actions, we had a switch statement. So here's an example of what those functions do. Here we're going to update the stock. We're going to take the data from that adaptive card that was posted back. And if we got back the new stock value and a product ID, we'll go ahead and update the product. And then what we're going to do is just show another adaptive card. We're going to swap that adaptive card for a new one, substituting in the new value, of course, for inventory status and for the stock count, etc. Now I put a link to the sample code down in the show notes so that you can get to that. And I also put a link to our app camp labs where you can learn a lot more about message extensions and Teams Toolkit. Really does make it a lot easier to build this type of solution. If you have a business application that could benefit from Copilot integration, why not consider writing a message extension for it now? Even if you don't yet have Copilot, your message extension will be useful to users right away, and then it'll light up in Copilot when you go there in the future. So why wait? If you liked this video, please don't forget to hit the like button. That really helps us out. And subscribe to this channel so you can stay up to date on all the latest advances in Microsoft 365 development and in Microsoft 365 Copilot. Thanks for watching, and I'll see you next time.